It says that consider the method used by the process 1 and process 2 for accessing critical section. Initially, value of shared Boolean variable S1 and S2 are randomly assigned. So we have two processes. So there is process 1 and process 2. See, both the processes are actually using the shared resources. So both need to be to do the inter-process communication, and this communication is in the form such that the system consistency should be maintained. So for that we have seen, if we have two processes, so if we'll apply the Peterson solutions where we talked about a variable, and we have actually two variable. One is the Boolean variable or the integer variable where we have the value 0 and 1, and another are the array in which we have the size of 2, where we find out the interest of the process, whether it want to access the critical section or it don't want to access the critical section. Based on these two variable, we have given a solution of process synchronization for the critical section problem. Now let's see this particular problem. Here we have a while loop, and it says that S1 will be equal to S2. If it satisfies, it will go in a loop. Otherwise, it will go to the critical section, and the exit section says that S1 will be equal to S2. So whatever the value of S2 is, will assign to S1. So this is a continuous loop which is going on. In the same way, we have another while loop. It says that S1 is not equal to S2. If this is a situation, it will go to the infinite loop. Otherwise, critical section will going to execute, and here will assign the value of S2 to not S1. Here it says that there are two processes P1 and P2, and there are two shared variable, Boolean variable S1 and S2. So if we have a Boolean variable, definitely it has two value, true or false, 0 or 1, right? And it says that you can choose the value of S1 and S2 randomly. Now, what is the question? The question is this. The option says that the first option is it achieve mutual exclusion as well as it will achieve progress. Option B says that it will achieve mutual exclusion, but it will not going to achieve progress. Option C says that it will not going to achieve mutual exclusion, but it will achieve progress. And option D says that it will not achieve mutual exclusion as well as it will not achieve progress. So these are the different options, and we have to find out if we have these code available, which is the entry section code, exit section code, entry section code, and exit section code. So it will achieve mutual exclusion or progress or not. So we'll try to find it out, the answer for that. Now it says that the S1 and S2 value you can choose randomly. So whatever value you want to choose, you can choose it. So let's start the value of S1 and S2 with 0. So let's say if S1 and S2, so I'll write it like this. Let's start with 0, 0. And we'll try to find it out what is happening. So if we'll start with 0, 0, and if process 2 want to execute P2, so it says that while S1 not equal to S2. So it says that 0 is not equal to 0 is true or false? It is false. So if it is false, then critical section is going to be executed by P2. And after that, what will happen? S2 value will be assigned to not S1. So S2 will be assigned to not S1. So S1 is 0, not S1 will become 1. Right? So that will happen when we execute P2 first. And after that, there is a 0 and 1. And let's say after that, P2 again want to execute its critical section. So it has to execute the entry section. Entry section says that while S1 not equal to S2. Here it's satisfied, right? 0 is not equal to 1. So if 0 is not equal to 1, it is true and it will be in a loop. So definitely P2 is not going to execute if S1 value and S2 value are different. If both are same, then P2 is going to execute. Here in this case, P1 is going to execute. How it will be? Here the entry section says that S1 will be equal to S2. If it is true, then it will go to the loop. Otherwise, it will go out from the loop. Because S1 value is 1, S1 value is 0, S2 value is 1. So 0 is not at all equal to 1. So it will be, this particular condition is false. If it is false, it will come to the critical section. It will execute the critical section. And at last, what it will say that whatever the value of S2 is, will assign to the value of S1. Now what will happen? Now P1, if P1 want to go to the critical section again, it will not allow because the value is same. If the value is same, it will be in the loop. So P2 is going to be executed because it says that S1 is not equal to S2, but here it is false because 1 is not equal to 1, it is false. And it will go to the critical section. So you can see here what we have the solution, the first solution that we have seen where we have the strict alternation, right? So that is also happening here. Now let's talk about, so we have seen how this this particular process 1 and process 2 is going to be executed. Let's talk about mutual exclusion first, because we have to see whether which particular option is correct. So we have to see for the mutual exclusion. Let's say we'll start with 0 and 0. And if we'll start with 0 and 0, definitely P1 is not going to execute, P2 is going to execute. Let's say P2 is executing and it is in their critical section. So if P2 is there in the critical section, so there is a critical section and P2 is executing into the critical section, means P2 is here. Why? Because 0 is not equal to 0, it will be 0 is not equal to 0. So here 0 is equal to 0, right? So it says that 0 is not equal to 0. So definitely it is false. If it is false, it will go to the critical section. So let's say P2 is in a critical section, and at the same time, can we put P1 into the critical section? So let's see if P2 is in a critical section, and here we'll preempt. Now what will happen? Now we'll go to the P1 and we'll try to execute the critical section of P1. So here the value of S1 and S2 are 0 and 0. If it is 0 and 0, this condition will be true. And if this condition will be true, the P1 will be in a loop. It's a bounded waiting, or you can say it will wait for a finite or infinite period of time. And then P1 is never going to execute in the critical section. So here you can see that if one process is there in the critical section, this algorithm or this particular solution is not going to allow other process to go into the critical section, right? If one process is already in the critical section, so it will not allow, let's say P2 is in a critical section. So this solution will not allow P1 to go to the critical section, right? So you can see that mutual exclusion exists. So if the conclusion is mutual exclusion exists, so which particular option is false here? It says that mutual exclusion doesn't exist. It is also saying that mutual exclusion doesn't exist. So these two solutions are wrong. Yes. Now we have checked with the mutual exclusion and we find out that the mutual exclusion is achieved here. Now, if mutual exclusion, now let's go to the progress. Progress says that if the critical section is free, so we'll allow the any interested process to execute into the critical section. Second thing says that if process are not interested to execute the critical section, will not make the process forcefully to execute into the critical section, right? Now here what is happening? Here when we'll start with 0 and 0, P2 is executing, and once P2 has been over, the S2 value will be 1. At that particular time, if P2 want to execute here, P2 cannot execute, right? Because there is a condition 0 and 1 is there, which will be 0 is not equal to 1, so that will be true, and P2 will be in a loop. Because P2 is interested, but this algorithm is not at all allow P2 to execute into the critical section. So you can see that progress doesn't exist, right? Here also you can see that if we have the condition 0 and 1 and we are executing P1, and after executing this P1, the S1 value will be updated to 1. If we have 1 1 after the completion of P1, and P1 again want to go to the critical section, so can we allow? So P1 is interested to go into the critical section, but because of the condition 0 and 0, it will be in a loop. It will be in a loop and never going to get the critical section to P1, even though P1 is interested. Here we have the strict alternation. Strict alternation means at that particular condition only P2 is going to execute. And if we have the condition like this, then definitely P1 is going to execute. So if S1 and S2 value are different, P1 will execute. If S1 and S2 value is same, P2 is going to execute. So here forcefully we are saying that you execute your critical section. So progress doesn't exist. Progress doesn't. So the rest of the option in which progress doesn't exist is true and progress exists is false. So you can see that the option B is the correct answer for this particular question, right? So I think you understood this. Let's try to see another question. Another question related to the same concept. This particular question is of GATE 2015. Let's try to solve it. We have process X, and or you can say process 1 and process 2. Okay, let's see the logic. Logic says that we have a while loop which is always true. Here also we have a while loop which is always true, and inside that we have a logic. We have variable P. We'll make it the value as true, and we'll go to the loop, and the condition is variable Q should be equal to true. If it is true, it will go to the infinite loop. Otherwise, it will execute the critical section, and after the critical section, the P value, the variable P value, it will make it false. Let's go to this. Here we have variable Q, which will make it as a true. In the while loop, we'll say variable P is equal to true. If it is, then we'll go to the bounded wait, and then we have a critical section, and the variable Q will be equal to false after that. So you see, this is the logic in this particular Okay. Wait a minute. Here it is. Here it is variable p only. It is making s true. Okay. So this is the logic which is there, and the option we have. The first option says that about the mutual exclusion, and second is the deadlock. So we have four options. So it says that mutual exclusion doesn't exist, deadlock doesn't exist. Mutual exclusion exists, deadlock doesn't exist. Mutual exclusion doesn't exist, deadlock exists. And the last one says that mutual exclusion and deadlock both exist. Okay. So let's see this particular problem and try to understand these two. So we have two variables. One is the variable p, another is a variable q. Let's start the process with false. If both the Boolean variable are false, then what will happen? Let's say if both the variable are false and we'll try to execute P1. So if we'll try to execute P1, we have to do variable P as true. So this will become true. If this will become true, and then we'll go for the while, and it says that variable Q equal to true. So what is the meaning of that? Variable Q equal to true. Here it is false, right? It is not equal to true. It is actually false. So this condition doesn't satisfy. So we are going out of the loop. We'll execute the critical section and we'll make variable P as false. Okay. Now we are in the previous condition, means false and false. So we have started with false and false. Right now also we are in the false and false. Let's see at that particular time P2 want to execute. So variable Q, it says that variable Q equal to true. So variable Q, it will make it true. And then it will go to the while loop and see variable P is equal to true or not. So variable P is not true. It is actually false. So definitely this condition is not satisfied. It will go out of that and execute the critical section. And after that, it will execute the exit section. Exit section says that variable P equal to true. So variable P equal to true. Right? Now, which is going to execute? So here you can say, if both are true, then which is going to execute? Now let's say P1 want to execute, then what will happen is variable P, it is making as true. Variable P is already true. He doesn't have to do another updation. Now, while a variable Q equal to true. So variable Q equal to true. Yes, it is true. So if it is true, it will go to the loop, right? It will go to the loop. So P1 is not going to execute. Now come here. Can we execute P2 here? So variable Q equal to true, variable P is also equal to true. It will also go to the loop, right? So here you can say that if both are true, then nobody is going to execute, and both will go into the loop. So both are going to the loop means deadlock exists, right? So which option says that deadlock doesn't exist? These two options says that deadlock doesn't exist. So these two will be cut it off. Now we'll see here in this both but deadlock exists, but we'll see with the mutual exclusion whether mutual exclusion exists or not. So do you understand what happened here? When both are true, so this option will be true and this option also will be true. If both the option will be true, both will be in a loop. So if both will be in a loop, definitely it will go to the deadlock position. Means P1 never going to execute its rest of the instruction, and P2 also never going to execute its rest of the instruction, because both are waiting this variable Q to be false, or it says, this one says that variable P should be false, but here it is not happening. So both will go to the loop and it will be a deadlock. And what about mutual exclusion? Can we say that mutual exclusion exists? So for that, we have to see the condition where one is in the critical section and we do not allow another to go to the critical section. So let's say we have the value false and false, and P1 is executing it. So what it will do is it will make it variable P as true, and it will go to the loop. Loop says that variable Q is true, here Q is false, so it will be false, then it will go to the critical section. Now here, once P1 is in the critical section, you have preempted and you want to execute P2. So P2 want to execute its critical section. Let's see whether it can do or not. So here it says that variable Q equal to true. So variable Q equal to true, it will make it variable Q to true. And after that, it will go to the while loop and says that variable P is true or not. So here you can see variable P is already true. It will be true means the whole condition is true, and the while loop will not go out from the while loop because this condition is satisfying. So we are in the loop. So if we are in the loop means if P1 is already in the critical section, so P2 is not allowed here, right? Because it is in the loop. Let's talk about the reverse one. Reverse one means, let's talk about P2 is executing into the critical section. Now P2 want to execute into the critical section. Then what will happen? So both are false here. Variable Q equal to T. So we are making it to true. And then we'll go to the loop. Variable P is true. No, here it is false. It will go to the critical section and P2 will be executing. Let's say P2 is in the critical section here and will preempt. And we want that P1 will be executing its critical section. So let's see here. It will make it variable P as true. And it will go to the loop. It says that variable Q equal to true. Here variable Q is already true. It means that condition is true. If this condition is true, P1 will be in the loop. So if P1 will be in the loop, it will never going to execute the critical section. So you can see mutual exclusion exists. Means if one process is in the critical section, then other process will not be allowed. So mutual exclusion exists in this particular case. So which option is correct in these two? So mutual exclusion exists. This option is correct. And this will cross it up. So here mutual exclusion exists as well as deadlock is also exists in this particular problem. So I think you understood